All right, I've just got a couple questions, then I'm going to turn it over to you guys, and y'all will wake up. Yes? Yes? So let's start real fast with Stu, because, because I cover broadband. I spend a lot of time playing with phones, loving all sorts of networks. You know, I don't necessarily care that they're networks, I just care that they work. And I know that the revenue crash is coming for you guys, or the revenue is going up, but the profitability, it's going down. So when I listen to you talk about that and say that software-defined networks can help because they help eliminate some of the higher cost gear that you guys buy, some of that telco class stuff, I have to wonder, what does that mean for someone like Dave?
Dave seems pretty confident, actually.
Hi, Stu.
He's pretty confident.
Dave, I'm going to ask you too. This is for both of y'all, really.
Oh, but no, I'll answer more seriously. I mean, I tried to stress that things don't change completely.
They don't.
We still have class 5 switches in the network. I mean, right. So things have to coexist for a long time, and you can do one of two things. You can really just let some technology sit there and dwindle and not do anything. Or if there's a viable path to move it into the new world and use it and still reap value from it, then you do that. And I think that's what Dave was describing.
Do you think that a proprietary or a vendor used to selling to the telcos can adapt to that world? And I ask this not just because I'm picking on you, Dave, but also because I've seen it happen in the server and data center space with people still funding hardware-based companies to do really cool things that nobody buys in a commodity server world. So, I mean,
Are you picking on me or Stu?
no, I'm asking both of you. I mean,
Go ahead.
I guess I'm going ahead. So, yeah, absolutely. There's no end to high-end technology. There never has been and probably never will be. So, what are we doing as an industry? And I'll just not necessarily speak for Juniper, but for the industry, the really big boy transport gear, yeah, that's focused almost exclusively on bandwidth. And the stuff at the edge is focused on high touch, lots of features and programmability. And that's pretty much, if you take a look at the history of the internet, where we started off as who could build it the fastest back in the late 90s, got the biggest market share, swung to who can solve my sparing problem, and made the pendulum swinging right into the middle, where we're building network function specific devices and network function specific ASICs and network specific function gear for each of the different locations of the network that Stu has, whether it's the big transport stuff or it's the edge stuff. Same thing with Steven. So that's really where the industry, I think, is headed, is that we're all getting extremely specific towards the cost point and the functionality we need to optimize for. Core, it's bandwidth. Lots and lots of bandwidth. Unsatiable demand. The internet is incredibly popular, and so I hope it stays that way. But at the edge, it's massive flexibility, and I think it always will be.
Okay. Sorry, I've got pages of notes because I got so excited about everything you guys were saying. I did want to ask about, I don't know who was talking about it now, but the DNS, the location, so delivering a service based on location, based on how it would be fastest or better user experience based on the location and the quality of the network. Isn't Google and OpenDNS doing something like that? And isn't it kind of an IETF effort that's open source? Or I was unclear how that kind of related to.
So Alto, and you might have seen extremely quickly as I was talking that Alto, the application layer traffic optimization protocol and functionality, is defined at the IETF. There's something very similar with respect to content data networks and the ability to create content federations, which is also happening at the IETF. And so your question towards Google, and I'll see if answer this in a second, he has his own stuff that does a whole lot of this already. That's not at the IETF and not standardized. There's a lot of folks and a lot of applications that are either over the top or otherwise that could use this type of information. And again, well, that's the difference between the two businesses.
That said, we have a draft at the IETF to extend the DNS protocol to help open DNS resolver services like OpenDNS and like our offering give hints as to who the client was, so that something that's trying to offer services through DNS as a mechanism by giving inconsistent answers based on who asked, to enable them to perform better, knowing who it was that asked.
I want to jump in, though, because you guys are talking about DNS, and there's two different aspects. One, openness above and below, and I'll let you respond. But don't miss the point that I think at this point, I think we crossed over. At this point, more than the majority of interconnection is through mobile, right? And DNS isn't helping an awful lot from a location service point of view on mobile. It gets into triangulation of towers and actual GPS. And towards that, I mean, you see Verizon already has it. You see others in Europe actually have it at this point, where we're exposing that through APIs from the network. So you don't have to rely on the device or what the device does. You can ask the network as a developer, where is this? And depending on permissions and security, the network tells you where it is. So, I mean, you're talking about a very serious problem, but I think you have to look at the big picture of also mobility, which is really how a lot of people are attaching to their services now.
So, and I agree with you, Stu. So the third piece, we talked about DNS, let's call that for wireline or whatever the case might be. We've got mobility, and we've got a number of geolocation and geoproof stuff working at the IETF. And the last one, which currently is popular as well, certainly for web browsers, is web plugins, which again go back and query the network and find stuff where find things are located and trying to deliver the best experience. And there's obviously oodles and oodles of plugin that we put into our web browsers, again trying to steer the best experience over these networks.
All right. I'm going to let you guys ask some questions now to the microphones.
Richard Cox from SAP. Stu, I really enjoyed your reference to hybrid cloud, and Dave, I liked your reference to bandwidth calendaring. So Stu, you talked about bandwidth on demand. Dave, you talked about bandwidth calendaring. But it seems to me in the hybrid cloud use case, the user doesn't really want the bandwidth. What they want is just to get this data over there. And so it's really about, move me 10 terabytes faster than FedEx can. And I'm wondering whether you guys are talking with the Internet 2 people about not thinking about megabits per second, but just thinking about, terabits when I need it. I'll tell you when I need it.
So to be honest, the Internet 2 applications we've been focusing more on with ESNet, to be honest, and ESNet because they're the really, really large sensors moving giant amounts of data from CERN or other large experimental sensor locations where they do need to move 10 terabytes and 100 terabytes. With users, and Stu, please jump in a second, but enterprise users and those that are doing cloud bursting need to be able to either do this potentially on demand or at a scheduled time, where the biggest problem that we have trying to solve this from a network point of view, is it water filling or a bin packing algorithm? Are we going to move other traffic around to make this fit? Data center backup kind of becomes a classic one where you really get to select the time, the priority, et cetera, that's occurring at that particular time. So I think this is huge, rich opportunity because there's a multitude of algorithms. Anybody that tries to ever do a calendaring or scheduling algorithm realizes how difficult it is to predict the state of a network in the future when you only know what's going on today or what has happened. It's close to impossible, but nonetheless, it's extremely ripe for research, and I2 would be a great place to do it.
Yeah, I would say I was certainly using a terminology that's very familiar within the circles of telecom, but I wasn't inferring that there actually is any knowledge of the user of what the bandwidth is. I mean, in sense of moving a data set, you're talking about really what and how are you moving it? Is it a block transfer? Is it some page movement, page shifting of copy? It really gets into the application orchestration that has to translate that into something meaningful for the network. So understood, it's not that the user's coming up and saying, oh, I know I need 1.3 gigabits now for the next 20 minutes. That's not the case.
When we're talking about, when I'm hearing you say, Stu, about what Verizon is trying to do, I hear you guys becoming less of a network company, which is what many people think of as Verizon, and becoming much more of we'll call it a services, we'll call it an app-focused company, which makes sense when we think about an all-IP world, because that's kind of the currency. So do you really see that Verizon or any kind of service provider really becoming more of that app provider and not necessarily divorcing themselves from the network, but not maybe, I don't even want to think of it as branding, but I mean, you're talking about selling services to CenturyLink and I mean, people that might have formerly been competitors.
Well, no, yeah, not really. Actually, we have a very strong wholesale business. Our biggest customer, is AT&T. I mean, that's reality, and that's.
It's at iPhone.
No, I mean at network, AT&T network, using our network. So it's no, that's part and parcel. So I wouldn't say no. I mean, being a good network company, I mean that's the problem is you get very focused. It's very easy to get focused as a large provider on the services that you've branded and want to sell, which is some small set of services, and they're not the lottery winners usually, right? I mean, voice and messaging were pretty good, but it's hard to come up with the next one. The reality is if we're investing in a great global network, its value is in its use, and we can monetize its use, and it's not going to be, that use isn't going to be driven necessarily in the future by the applications Verizon invents and sells. It's going to be making it a platform that can be used by as wide a range of innovative developers as possible that see value because of the way we've exposed things and how easy we've made it to use our network. I mean, that's sort of, think of it almost a long tail of monetization of the network, but it becomes very, very important moving forward.
So I would just add to that, from the user side, on the campuses, 10 years ago, we had a network director who was a very important person. And when we had someone who was in charge of storage or, the big systems, those people were the same people now. There are very few places that have a network-only focus in their organizational structure. It's about the infrastructure platform that supports the application. So I think that's right in line. It's certainly part of why we think SDN is so important for this national scale testbed is it's not good enough to have an IP network. We want to let the folks who are doing the applications rethink that. Maybe they pull in a little bit of IP, maybe they pull in a little bit of DNS, maybe they don't need those things. And they may choose to refactor this and build their network to support their applications in a totally different way, and we think that's important.
So one thing I was trying to express is that, and maybe it's that I completely disagree with something that Igor Gushinsky said yesterday, is that a goal of a network is not to be a big, dumb pipe. It's to be a very intelligent pipe, and I think Stu just said the same thing. I'm baiting Igor. It really was happening.
Igor, other questions? wait.
I let Igor because I know. Yeah.
Okay, I was going to go in fairness, but I'm like, he's got to have a chance.
No, he has to answer.
Yeah, so since you baited me, I'm going to bait you right back. So if you think that the goal of the network is to be this big, intelligent, smart thing that can also forward bits, a lot of them, right? And I saw some presentations here, it talks about, doing services over this network. Are you thinking of doing microflow programming of those services? And if so, how many decades before I see chips that will actually fit those microflows?
So,
and I'm baiting you right back.
Yeah. So you brought this point up yesterday. So no, down to the microflow? No. And that's really not what we've talked about yet, and it's certainly not really within our horizon of having, technology that can do that for us, depending on what a definition of a microflow is. But assuming that it's a one-packet flow, that you need to search randomly in that packet to forward it correctly, yeah, we're a bit away from that.
By a microflow, I mean...
Okay,
like
I'm going to let you
TCP
guys set up
flow.
your straw men outside, and y'all can knock them down. Go for it.
Alex Bachmansky from Ericsson. A question today, we had many presentations where actually we look at the SDN architecture with multiple controllers, even self-programming of users. In Dave, there was PC trying to configure one thing and controller trying to configure exactly the same thing probably. So one question is here, it's good that SDN abstracts the network, virtualize the network. We don't know anything about physical properties. It's also a disadvantage because we don't know what it is. So two different entities can try to program totally, the same entry with two opposite sides. I'm good programmer. I could probably, let's say, I want to have some denial of service attack on Google. Okay, it's the service. So I configure a service that blocks the traffic that is going to the Google, and Google wants to unblock that. So now we have collision on one entry somewhere in the TCAM of whatever device over there that nobody, neither me nor Steven even know that this is this entry that is collided there. How the architecture solves that? I don't see currently anything in SDN that actually goes and fixes the problem real problem that we will see in the network when we have multiple controllers and multiple entities trying to program a single entity, or let's say, doesn't have to be the single, but at least a collided entity.
No,
So that's first question.
No, so I understand your point. So I do agree today that in our current discussions at ONF, we haven't really started our discussions with the hybrid forwarding plan of how to resolve these particular problems. But I do look back to a long history of building networking devices where there's a number of interfaces trying to program a device today, whether there's CLIs or multiple routing protocols or again, the NMS EMS interfaces where we have this exact same problem. This is a new interface. I think that these problems have been solved, and I think the problems have been solved on multiple protocols installing L3 entries, multiple interfaces installing the same ACL or conflicting ACLs, and there are ways to resolve this. Architecturally, before I get into details, right now the way it works generally is that the device, an individual router or switch itself, makes sure that there are not any errors or conflicts or routing loops on that particular device. We can continue with that architecture and fit in today's network, or we can take that exact same loop breaking algorithm or a similar loop breaking algorithm and conflict resolution algorithm and move this to the controller. Both are reasonable, both are possible, but I don't think this at all is an unsurmountable problem, because I think it's a demonstrated proof in multiple of them.
It is, or you need to have some kind of layered controllers, so you might need the hierarchy of controllers or whatever it is to break those problems, but at least what I'm saying right now, it's not even on the picture.
There are implementations that solve this.
So if you look at what these guys are trying to do, right, they there's a layer of mechanism on which they implement policies that provide the mechanism for the next layer, right? So they want to build a system that flexibly allows researchers to allocate VLANs on a nationwide network. They probably don't want to oversell their capacity or sell the same VLAN tag twice. That would be bad. But there's always a system that provides mechanisms, and on top of that, you define policies that constrain the mechanism's use to what the operator intends. Everyone who's
Steve, sorry, I'm gonna cut you off, just because we have 5 minutes and I've got like 3 questions. And well, okay, go.
Okay, hi, this is Robert Raszuk. A question for Stuart from Verizon. One of your slides, you drawn the dotted red line and said that these are the old-fashioned internet and OpenFlow was way above the level. So what do you think personally about the projects like RouteFlow, which try to merge the internet routing with the OpenFlow SDN technology? Is it no room for that in your network?
No. I was trying to illustrate that there were really sort of 3 levels, and you're presenting a 4th that wasn't drawn on the diagram, where in an environment where we're using SDN and using OpenFlow, it doesn't mean that everything is going through SDN or SDN and OpenFlow. If you're, we have to have routers to get out to the backbone, right, at this point. And again, we have them, so there's sunk costs, they're in the network. So if you're on a web page and you're just going out to Google across the Verizon network,
it would be nice for that to keep working.
That would keep working, and there's no motivation financially for us to change the way that flows. That's what that was showing. It was showing that you could do things all the way at the top, pure software forwarding, not using switches at all, but really kind of virtual switching in software, and then trying to illustrate that then you have a hybrid as well, where you're hybrid in the sense of using software, aware routing with OpenFlow. So I think what you're asking is, yeah, there was another, probably many more lines and use cases we could have drawn on there. I wasn't trying to show that by not having a line there means we've ruled it out. No. Okay?
I don't know who was first. We'll go this way because, he's ceding the floor to you.
This is for Stu also. Stu, in your cost curve, the new one, were you hoping to shift it so that so that it looks linear, or are you actually talking about structurally changing the scaling properties so that you get rid of the knee in the curve?
Yes, structurally changing the properties. Basically, I mean, we can do incremental things today, and we are. We're doing a lot of incremental things that are shifting out the knee, right, trying to avoid that crossover where our margin goes to 0, our profitability goes to 0. But you can only do that so long, right? I mean, at some point it makes sense, what's another technology to apply to the problem that improves the underlying structure and trend line of that? And it does seem right now that the technologies that have emerged for commodity computing and cloud computing are more aligned with the revenue curve that we have. So again, just trying to line those up.
And how disruptive are you willing to be to the network? I mean, the hardware, software, routing protocols. How far can it go?
It's going.
As a vendor, how far can a vendor push it?
It will go as far as we need to go with it. I mean, we're starting small and isolated in very specific use cases, and again, if we just bought a brand new router, it's not likely I'm going to want to pull it out, 6 months from now, right? I'm going to.
Thank you, Stu.
Yeah. So
Although the idea of cheaper data plans is key. All right, let's go. Ask fast.
Yeah, I'll ask quickly. There's been a lot of possibilities with software-defined networking. Some are technically possible but have political challenges. One of those that I've seen speculated is the idea that slicing of the network and the ability to add differentiation value into different layers and programming different things that haven't been programmed before could conceivably enable more shared services models to create more efficient economics between different carriers, but clear political challenges there. Do you see anything longer term that could conceivably be a trend, or political barriers insurmountable?
I think you're asking me.
Or the FCC.
Or the FCC. I was looking behind me to see who's going back. No, I mean, honestly, if it makes sense, I mean, we talk about things like the appliances, like CDN federation, and there's a lot of peering and federation takes place between carriers at all different levels and services. If this became a viable way to improve efficiency of some service level peering, if you will, which you don't really have today. We just really have to sort of transport MPLS down, maybe voice peering, but to make it more broad, yeah, it would be considered. I don't see there's a hindrance other than most carriers, including ourselves, are going to want to figure out how to do it efficiently ourselves before we worry about how to interconnect to the next guy. So it's an evolution.
Oh, perfect. You guys are free to go, and let's thank our panelists because they were awesome.